Thank you. So, yeah, I'm pleased to be here, and I'd like to share with you some work that I've been doing since about August last year, since the last PyCon, and so with the intention of improving the 2 to 3 compatibility effort. Okay, so I'm with Python Charmers, and we give training courses and some consulting in Python, particularly for data analysis. I'm grateful to Python Charmers for sponsoring my work on the Future project, which I'm going to show you today, among other things. And so these are some of the organizations we've trained in Python. And there's this question that comes up, Python 2 or Python 3? And it was really looking for the answer to this question that sort of led me down this path that I started on last August. So now, first of all, Python 3 is backwardly incompatible. And so what that means is that the last version of Python 2 was 2.7, released in sort of late 2010. Okay, so it's almost 4 years old. It's sort of over 3.5 years old now. And so any further Python 2 code you write is deprecated in a sense. And so this is the first interesting point. So there won't be a Python 2.8. Guido's re-emphasized this at the most recent PyCon this year. And despite calls for a Python 2.8, it's not going to happen, it seems. So where does that leave us? Currently, the uptake of Python 3 is relatively small, but it is improving quite fast. Okay? So now, here's a quote from last year's PyCon. So this is Alex Gaynor. I don't think he said it in a talk, but it was perhaps just sort of a hallway track or something like that. It's quite sort of pithily summarized here that Python 2 is deprecated in a sense. So it's not going away. There's going to be support for Python 2 from Red Hat and others for a long time. But it's not going to be getting any better. Okay. And so here are some reasons to love Python 3. First of all, it's made Python 2 a lot better. Okay. So lots of new features in Python 2.6 and 2.7 were just backported from Python 3. Unicode handling is a lot better. It's sort of one of the major sort of arguments for why there should have been a Python 3 in the first place. It's simpler. It's easier to learn for beginners especially. It's more consistent. Especially the standard library is much better organized. And there are lots of new features. Okay? So I won't go into a lot of the new features, but these are just some of the standard library modules, which are new. Well, I guess Decimal's not new, but it's been rewritten, so it's up to 300 times faster. This is, it sort of made its way in there accidentally in a way, but I'm pleased to see that in the next version of Python 3, 3.5, there'll be this at syntax now for matrix products, okay, dot products, which is great for people doing data analysis and science and engineering and financial engineering in Python. Okay, so there's a lot to like about it, but here's an angry mob. Here are some reasons to hate Python 3. Most people can't benefit from it yet. And Python 2 has been stagnating as a result because it's the end of life, or the end of new features in that line. Some large Python 2 code bases will never upgrade. It's interesting that Guido, I think, is still at Dropbox, and Dropbox has announced their own JIT compiler called Piston, I think, for Python, and that's going to be Python 2 only. And Dropbox is not unique among organizations having a sizable Python 2 code base, but it looks like they're in no hurry to upgrade, and the same's true in other places as well. Okay. According to Armin Ronacher, handling byte strings is a lot harder in Python 3 than Python 2, or can be. So I suppose he's, in a way, on the bleeding edge. He's at the interface between bytes and text in a lot of the packages he supports. Werkzeug and Flask and so on. So he's kind of at the coalface in a way, and sort of bearing the brunt of the difficulty in separating out bytes and strings. But for most of the rest of us, it seems to be simpler and easier. But for some segments of people, it's the community, it's more difficult. Okay. So now here's a quote from Guido a long time ago. So those warts that can be fixed without breaking compatibility are getting fixed in an evolutionary way. And he was referring to the intended release process for Python 2.6 and 2.7. This is before even Python 3.0 was released. So that has happened. There's now Python 2 syntax, you might visualize like this, and Python 3 like this. And there's some subset where there's an overlap. Okay? But there are various sort of features that for forward compatibility with under future. And what this does is to extend the reach of Python 2.3 compatible code out in the direction toward Python 3. Okay? So there are various other features as well that were introduced into Python 2.6 and 2.7, which are not here, but which also extend this out in this direction. And it's gone quite a long way. So it's certainly a lot better than the situation was in Python 2.5. They're a lot closer, but there's still a gap. So anyway, here are some of the benefits to Python 2.6 and 7 from the Python 3 process, when really everything was up for consideration and nothing was off the table, it seemed. So as is now a keyword. We've got set literals, we've got string.format, set and dictionary comprehensions, and more or less ambiguous exception catching. And we've got various new modules as well. Okay? So there are various benefits that we all enjoy, which came from the Python 3 process. Now, just some comments on Python 3 migration. So there's this site, Python 3 Wall of Superpowers. It used to be called the Wall of Shame, when most of these were red. This is actually a picture that's about 12 months old or so. So it's a lot greener now. There isn't very much red at all these days. So that's the former Wall of Shame. And there's this site as well, py3readiness.org, which uses a relatively new script written by Brett Cannon called Can I Use Python 3, which goes off and looks at your requirements.txt file and analyzes your dependencies to determine if they support Python 3 or not. Okay. Just a couple of resources. This book by Lennart Regebro is very good, porting to Python 3, and it's available online free. And he sells sort of the physical version as well. But it's clear, well-written, relatively short, but it's got good information. And the appendix of this is fairly useful. This is available online too. But in general, the other book has more information. Okay? Just a couple of resources. And now 2-3 is a script that Guido wrote and started writing, it seems, back in 2006, perhaps even earlier. So while he was at Google and started thinking about the Python 3 process with the other core developers and discussing it, so March 2006 or so was when that got underway with a new mailing list. There was this Python 2-3 tool that he wrote, which was designed to translate code from the old idioms to the new idioms. And it wouldn't be perfect. That wasn't the kind of expectation, but it would end up going quite a lot of the way toward offering Python 3 sort of code. But it's one way. So this makes it useful only really for projects that can abandon Python 2 compatibility. So that rules out libraries, really, because there's the chicken and egg problem in a way, sort of migrating. So if you migrate your fancy library to Python 3 when most of the users are still on Python 2, then they won't be happy about that. So there's a need to maintain 2 and 3 compatibility, which wasn't really foreseen at the beginning of the process. So this tool doesn't handle that. Okay. Now, I'll talk about Python 2.3 compatible code in a single source code base now. Okay. So first of all, there's the 6 module, which is fairly old. It's written by Benjamin Peterson. It's being updated, though. It's fairly small, about 750 lines now, and 59 tests. And it supports old versions of Python, so further back than 2.6. This is quite difficult to do. I'd suggest not bothering with that. So I think it's necessary sometimes to draw the line. Where I would draw it would be Python 2.6 would be a minimum you'd attempt to support with that together with Python 3. And the same way with Python, on the Python 3 side, I'd recommend just starting with Python 3.3 as a minimum, because the U prefix for string literals has been resurrected. So, but I'll come back to that. But yeah, this does support older Python versions as well. So it's only one file, one module. You can just kind of incorporate it. You can copy bits into your code if you like. So it's useful, but it's small, so it doesn't do very much. It just really supports the bare essentials. So it makes it possible. It doesn't make it easy. It makes it possible to write Python 2.3 compatible code. And so now the Python Future project is another effort in this direction. And there are 2 main packages, Future and Past. Future does a bit like what the under future imports do. So it's backports of functionality from Python 3 to Python 2, so it behaves the same way. And Past goes in the other direction. And then there are these 2 automated scripts, which are based on that 2 to 3 tool, which Guido and others wrote. And the purpose of Futurize is to turn Python 2 code into code that runs on both platforms. And Pasteurize takes Python 3 code and turns it into code that's compatible on both. Okay? So they're both using lib2to3 as an engine, and with various custom fixes on top of that. So there's the site. It's MIT licensed. There are about 37,000 lines of code, 850 tests. And most of the tests actually come directly from the Python 3.3 test suite. Okay, so that's been a big help. Basically just copying and pasting lots of Python 3.3 tests into Future, with currently about 1150 commits. So it's been going since about August last year. And there have been quite a number of contributors now, both of patches and ideas. So here's a list of them so far. And so as I showed you this before, so the purpose of these under Future imports is to extend the syntax. It's really syntax mostly that it modifies. So you can write code that's more like Python 3 code, even though it runs on Python 2. And the initial idea of Future was to allow this. From Future import star, and then just have Python 3 code, which automatically runs on Python 2. So I got this idea from that frustration I mentioned before about which language to teach. And also from Richard's talk last year, which was entertaining and fun. And he said, don't do this. But I had some great ideas. I thought, oh, great. That's what I can do. So it showed me a way to do what I've been wanting to do, but I hadn't really sort of seen ways to do it. So it started off with this sort of idea of it being very magical. Import auto 3 to 2, and then just write your Python 3 code. So just after PyCon last year, I sort of contacted Nick Coughlin and Richard Jones and Ryan Kelly and asked for their opinion on this idea, because they were 3 people whose opinions I respected, and I wanted to hear what they had to say. And they gave me some valuable early feedback. They did also generally say, no, don't do this, which is kind of what Richard said in his talk, don't do this. But I went and did it anyway, and that was interesting. So now, 2 people I found inspiring are Travis Oliphant, and in 2003 he unified numeric and num array into what's now NumPy. And really that healed that schism in the community, which allowed Python to kind of leap forward in being such a valuable language in science and engineering. So without that, it would have been much more difficult, because some segments of the community were on each, and there were advantages and disadvantages to each of them. But not having the unity really slowed the community down. And I think that's happening now in Python between 2 and 3. And at least that's something I've been wanting to avoid, that fragmentation. So another is John Hunter. He was the author of Matplotlib, and he sadly passed away, I think, about 18 months ago. And but before he did, he gave a talk on the state of Matplotlib, and he related his early experiences developing it, and said that when he first of all got up in SciPy and presented a new plotting package, various people were telling him no, he shouldn't do that. He should contribute to some existing ones and make those better. But he went ahead and did it anyway. So that's interesting. So, and then there's this question, which is interesting to ask yourself. So if not me, then who? And this can be, yeah, a good question to ask if there's any change you want to see in the world, I suppose. So, so as I've gone through this process of developing Future over the last 12 months or so, I guess that the vision for it has sort of evolved or unfolded over time. It didn't really spring kind of fully formed into my head or anyone's head of the contributors. It's really something that's kind of expanded and with progress. And I think that's something I've learned, which is interesting. And also there's this sense that I've had this, it's, as I've proceeded, and I've sort of discovered more about what's possible. So the various things I've discovered, like this under instance check, I didn't know this existed, and this really solved a problem with the design of the Future package with instance checks for the types. I'll show you those later, but anyway, this kind of basically, it was already there. There's an existing PEP for it, and it just solves the problem, but I wasn't aware of it at all. So, and the fact that, yeah, object is something that can be overridden and that can be a useful thing to do, that's interesting too. Here's an interesting lesson. So if you break something, change its name. I'll come back to this tomorrow. I'm giving another talk tomorrow on how to upgrade a platform more generally, including web APIs and any kind of interface. But that's an important principle. And it was applied to some degree with the Python 3 process, but there were many instances where it wasn't. So yeah, that's interesting. Now, it turns out that shadowing built-ins is actually simple and effective and unproblematic. It's a great thing to do. And it turns out that import hooks, which are defined through the PEP, there's an existing mechanism for them, and so they turn out to be a bit of a mess. So there are some interesting sort of lessons there that around Python itself I didn't expect to learn there. So essentially what Future offers is various built-ins, for example, which extend this even further out in this direction. So the idea is that Python 3's built-ins, these ones, these are the ones that are different. So Future.built-ins provides these, and I guess there are, what, 20 of those. Okay, so they're all different in Python 3. And if you import these on Python 2, you get the same behavior as Python 3. That's the guarantee. And in Python 3, if you import these, nothing happens. Okay? It's just shadowing the built-ins with the same built-in functions, so there's no effect. Okay? So that's the idea, that on Python 3, there should be no namespace pollution or anything, even from Future.built-ins import star. And on Python 2, it should allow you to write Python 3 code, and then it should run, ideally, unchanged. Now, there's also this past package, which is a kind of more recent addition, which goes in the other direction. I didn't think this was possible initially, or I didn't sort of particularly, didn't think it was worth pursuing initially. But it turns out to be quite useful. And I'll show you a couple of instances of that later. But there are 19 of those sort of resurrected from Python 2, which are now available in Python 3 again. Because so many of these were either changed or removed completely in Python 3. Okay, so that's interesting too. So yeah, it's just general advice, I suppose, that applies is improve your test suite. Then there's this futurized tool, which comes with Future, which is 2 to 3 based and will give you a patch for your code. And then you can sort of fix up Unicode and then test under both platforms. Okay. So now, various idioms that I'd like to run through. How are we doing for time? Okay. Is that to the end of questions or to the start of questions? Okay, thanks. Okay. So this is in 5 or 6 parts, these idioms. Okay. But each one's fairly quick. All right, first of all, syntax, print. This is Python 2 only, so it's deprecated. So I saw 2 of these print statements yesterday. I saw some print functions as well. This is compatible with both platforms. So as far as I'm concerned, it's the one to use. Okay? It's not really any harder, and it's forward compatible. It just makes sense. So I think this is the idiom to adopt. Okay? Now, the reason the print statement was removed is because it's kind of clunky and unusual. Like this isn't standard, it isn't kind of consistent with anything else in the Python language. So, so this can be changed to this. Now, in Python 2.6 and 7, there's this print function, which is available. This sort of modifies the syntax and the grammar of the language on the fly to allow print to be used as a function, just like in Python 3. Okay. So this is a standard feature of Python. Next, raising exceptions. In the past, could be done with a comma. Now, it's done like this. Okay? So you're creating a new instance of this class. Okay? So that's the compatible syntax with both versions. Catching exceptions is similar. So instead of a comma, we want to use this new as keyword. And this is compatible again. So anything in a yellow box is compatible with both platforms. So it's my recommendation for the idiom to use. Okay. Integer division. In Python 2, you could write 2/3 and expect to get 0. But in 2.6 and above, there's a double slash operator. So if you want integer division, then it's necessary in Python 3 and possible also in Python 2 to use a double slash. Okay. Now in Python 3, I put that in red because this is a bit different to the others. This gives float division. If you want to bring that behavior back into Python 2, you can use this here from under future import division. Okay, for forward compatibility. Now, sometimes it might not be so easy to know what the types of B and C are. Are they ints or are they floats or whatever? So in future, there's this old div function which behaves just like slash on Python 2. Okay? So if you want to force a compatible division, not knowing what the types are, you can use this idiom, and that works on both platforms. And this is something that can be wrapped by automated tools like parse.autotranslate, which I'll mention later if there's time. Next, octal literals. If you're a systems programmer or a system administrator, then you'll be used to using octal for file permissions and so on. It's now become this. Okay, so that's a syntax error in Python 2. Okay? And the rationale was that zero and as a prefix to some number, most of the world wouldn't expect that to actually change the number, but it did in Python 2. Okay, so that's not possible to make that mistake anymore as an unsuspecting newbie. So in Python 2, there's this L suffix for long integers. That's gone. So that's a syntax error in Python 3. And you can write this in both, and you'll get a long integer. Okay? So that's the idiom to use, removal L's. Now, relative imports are interesting. So if you're in, say we're talking about a module inside a package, like submodule 1 inside this package, and if submodule 1 wants to import submodule 2, in Python 2, that would work. But in Python 3, that doesn't work anymore. Relative imports have to be done explicitly. And so the idiom to use in both versions is that. That works in Python 2 as well. It's been backported. Okay? So this is the new idiom. And if you want to force that bit of extra safety on Python 2 so it behaves like Python 3 does, even if there's another file, you can use this from under future import absolute import, which prevents implicit relative imports. Okay, next part, bytes and strings. And this is the biggest difference between Python 2 and Python 3. Okay. So first of all, in Python 2, some strings which don't happen to have non-ASCII characters were sometimes written like that, unadorned without any prefix, and then Unicode strings might have been written with this U prefix here. In Python 3, all strings are Unicode unless they're not, so unless they've got explicit B prefixes. But this is the recommendation I'd use to kind of mark those up explicitly because it makes it clearer. And now, if you're writing Python 3 code, new code, and you're targeting Python 3 and you just want to provide Python 2 compatibility with that, then this isn't necessary. And you can use something I'll show you in the next slide. But for any code you're upgrading, migrating module by module, this will make it clearer. So here's an example of the Unicode function in Python 2. This is gone. Doesn't exist anymore. There's now this str, which behaves like the Python 3 string. This is available as a future.builtins type. Okay, so in Python 3, this does nothing. This is just the standard idiom. In Python 2, this will give it the same behavior as on Python 3 and the same behavior as this. Okay. And now, Jacob Kaplan-Moss said last year at a conference that he talked about removing string from your lexicon as a good way to think about upgrading to dealing with compatibility, because string is ambiguous somewhat, unfortunately. So if you want, you can rename it to something like text. If you see text in the context of compatibility between Python 2 and 3, then it's referring to Unicode, okay? And it's unambiguous. It's on both. Now with file I/O, you may be used to doing this, opening a file, reading it in as a byte string, and then potentially decoding it to a Unicode string. In Python 3, this is the idiom, and you can use this idiom in both. So in Python 3, you normally wouldn't need the first line, but it's available, so it doesn't hurt. Okay. Now this is nice. This open function has various new arguments like encoding, so you can make use of those, and this will just read it in directly as a Unicode, as a text string. Okay. So this is the idiom to use now. Yeah, it can really simplify code as well. Okay. These are gone. String I/O and C-string I/O modules, they're gone. Okay, so they're deprecated. They're not present in Python 2, in Python 3. But this I/O module does support a bytes I/O object, which had the same behavior as the Python 2 one of that. Yeah? And there's also a string I/O, which could equally well be called text I/O. It's the Unicode version. Now, if you're looping through characters in a byte string in Python 2, that idiom won't work in Python 3 anymore. At least this is the way to do it in Python 3. If you want to get the result as a byte string, you'd cast it to this bytes object, and we just have one of them. So it's a byte string of length 1 and see, if you loop through them, you get integers. This is something unusual. Okay? So that's the idiom now. You get integers, which is a number between 0 and 255 in a byte string. So on both versions, you can import bytes. Okay? So bytes has been backported to Python 2 in the future package. Okay? And this does work with high bit characters as well, like that. So now here's another point. So on Python 2, there's this unitrue function, which takes a Unicode code point and returns a character. And in Python 3, it's called this. But unfortunately, on Python 2, there's already a function called this, which does something different. So this is the idiom I recommend using. Okay? Again, just importing the Python 3 version and using that. Next, here's another way of doing it. Well, with this true, this is the old true function. So on Python 2, it did this. It gave you a byte string, and this works for numbers between 0 and 255. In Python 3, one way is to encode it using the Latin 1 encoding, because this will map all of those to the relevant characters without changing anything. Okay, so that's not a very good explanation, but it won't mess up your encoding for this, so it'll make this possible. All right. Another way to do this is on the following slide. You can use this bytes object from Python 3, or the equivalent on Python 2 there, and pass in a list of whatever integers you want. And it'll give you back a byte string of that length. Okay, so by the way, all of these are available as a cheat sheet. So if you see something and it goes through too fast, then I'll give you a link afterwards, and you can see this. It's about sort of 18 pages now. I'll show you the link to that. Now, if you're used to overriding the under-str method in Python 2, you might be used to using this kind of idiom, where this does most of the work, and this is what Django encourages, where this method does the work of actually returning the string, and this just encodes it usually to UTF-8. Okay, so the actual string is there. And that idiom won't work in Python 3 anymore, because there's no under Unicode. So how do we write compatible code with this? One way is to use a decorator, which is here, future.utils. It's come from Ginger 2. No, it hasn't. It's come from Django. So this is in Django.compat, or .utils.compat. So basically, I've swiped this decorator from Django. So this is very useful. So now you can just define it the standard Python 3 way, and apply that decorator to the class. So it's not ideal. It's a little bit more cumbersome than we'd like, but it does the job. Okay, next, type checking. Yeah, so base string has gone in Python 3. The idea is that bytes aren't strings anymore, so there should be no need to test for whether they are, or something like that. But so in Python 2, you might have this kind of code with two different sorts of strings, and just making sure that they're both base strings. In Python 3, I would first of all suggest explicitly marking up any byte strings with a B prefix. And if you do want this kind of behavior, you can import base string. It's been resurrected there using the magic of that under instance check method that I mentioned before. So that's how that works. So that is one option. But probably what you want to do is to refactor the code to avoid considering this B as a string, and instead decode it to a normal string, and then check this, and I guess that shouldn't be there. Okay, so that's the way I'd recommend doing that. Next, type checking with ints is interesting too, because the long from Python 2 has gone as well. This is Python 3 only, because long is not a subclass of int in Python 2. So this wouldn't work in Python 2 if it's too big. So one way you can test whether they're both the same is to import int, which is a subclass of long on Python 2. Once again, on Python 3, it does nothing. And then you can just do that check in the usual Python 3 way. So I guess what you'll see is that, so with many of these examples, my recommendation is the same. Write Python 3 code and just import the relevant things to make it work the same way. It's actually pretty easy to do. Next, lists versus iterators. There have been various changes in Python 3 to make more functions return iterators and not as many return lists. Okay? So it's sort of simplicity and efficiency by default. That's the idea. So in Python 2, range gives you a list. Now, In Python 3, it's an iterator, so this would be the usual idiom. But the problem, a slight problem, is that on Python 2, this would copy this memory. So list, if you pass in a list to the list function, it'll actually copy the memory, which is a bit wasteful. It's okay, it does the job, but it's a bit more wasteful than it could be. So if that's a problem, you can import range from future built-ins, and it behaves just like it would on Python 3. So it returns iterators. And map, zip, and filter behave just like range. Okay? So that example would pretty much be the same for those. So they've all become things that return iterators in Python 3. Now, dictionary keys as well. In Python 2, there's this iterkeys method. Python 3, that's gone. So in Python 2 and 3, this is what I'd recommend, just for key in heights. That's kind of efficient, and it works on both versions. Okay, so that's the idiom there. Now, if you want the keys as a list, the idiom to use is to just turn it into a list directly instead of list dot keys. Okay, that's the idiom there. Now, for values, it's a bit more complicated. Python 2, once again, there's iter values. Python 3, that doesn't exist. This is a bit less efficient on Python 2 because we wouldn't need this whole list in memory generally to iterate over them. So one option is to import this dictionary type, which is a subclass of a regular dictionary on Python 2, which has methods that return what Python 3 methods would. Okay? So values then returns an iterator. If you don't want to do that, or if you've already got a dictionary built, so it would be wasteful to recreate it again or something like that, then you can use this function, iter values. It's in 6 and it's in future.builtins as well. And you can just use that. So it's a bit less idiomatic, but it does the job. Okay. Now, custom iterators, this is interesting. So to write an iterator, we've got a next method on Python 2. And this might be a way to create this sort of iterator here. So if we turn this string into pass it into the upper class to create a new iterator object here, then we could normally apply the next method on Python 2. And we could we'd expect to get that back. Now, there are two other methods I've omitted here. One would be just to initialize it. One would be to return the define under iter. So that's Python 2 only. In Python 3, it looks like this, under next, which is more consistent with the rest of the language, which is good. But in Python 2, it hasn't been backported. So it's not so easy to do it. One way you can do it is to import object. This is a subclass of the regular object that, again, overrides that instance check method. So if you do this on Python 2 and 3, it'll work the same way as it would on Python 3 without this import. Okay. So that's a pattern you can use there. And there's another option there. If that one's too magical for you, there's this implements iterator decorator, which has come from Ginger 2 as well, I think. From Armin Ronica wrote it. Okay, so now the standard library. Okay, thank you. There's been a big reshuffling of modules in the standard library, and in Python 3 it's better organized, but that hasn't been backported to Python 2 the same way. So it's not possible to do this in Python 2, and these are all gone and refactored. So one pattern, which is a bit ugly, is to just try to import these things from Python 3, and if not, you can just pull them in, expect that it's Python 2. And a lot of 2.3 compatible code bases use this idiom. And it does work, but it's clunky somewhat. So if you want an alternative, either 6.moves or future.moves, they have a bunch of modules which kind of simulate the new interface. In 6.moves, they're all fake modules. So they're all actually created in code. They're not actual .py files. In future.moves, they are .py files. So it should be more robust in the case of dodgy things like py-to-exe packaging and Django's auto reloader and things like that, which have caused this one some problems in the past. Anyway, they're available. So that's one idiom you can use. And another way is that in future, there's this import hooks mechanism offered. So you can import this context manager called hooks, and then just import using the standard Python 3 idioms, and it'll bring it in. And the same pattern applies with all of the other 10 or 12 or so standard library modules that have moved or been renamed. Okay, so I'll skip over these other bits. Oh, yeah, function annotations, by the way. This is kind of the opposite. Going from 3 back to 2, you can actually define this. And this isn't written in the official PEP because it's out of date. But anyway, that's the way you would do it. But that's only useful for something like MyPy, which is kind of up and coming and interesting for static typing. Okay, I'll skip over the rest of these. And then I'll just say, if you want to support Python 2.6, there's a little bit of extra work to do. This idiom has to be used because set literals aren't supported. And this isn't supported, but this is. So you can just add zeros inside your braces, and that'll work. Those are the main differences I've encountered. Now, here's that cheat sheet I mentioned. It's available here as HTML. There's currently no link from the table of contents from Python Future, because I just uploaded it last night. And there's a PDF version there, too. Okay. Yeah. So now, I mentioned Futurize. This is a tool you can use to automatically convert old code to supporting both platforms. But there's more information on the website. And those are some ideas about where the future project can go in the future. So what I'd like to see it do. In particular, percent formatting has been resurrected for the bytes object in 3.5. So that'll be important for MySQL DB to migrate to Python 3, for example. They've expressed that it's been working well, but they've hit a wall with this not being available. But since it's now going to be available in 3.5, I'd like to see that backported back to be available as well. And there's a lot more that can be done with the past module, because I've realized that backward compatibility is actually a lot more powerful than forward compatibility in terms of allowing a community to upgrade. And pip currently breaks when Python 2 code is all that's available. So if you're using Python 3, you just it bombs with a syntax error or something like that. So there are sort of changes that need to be made to that. And ideally, there could be sort of pull requests sent to owners of packages on PyPy that are using Python 2 only code. And this can be automated using Futurize. And so I think the challenge for us as a community is to avoid fragmentation between 2 and 3. It's in nobody's interests for there to be fragmentation like this. And I think the sooner we're over this hump, the better. I ask you, please don't accept deprecated code. And that's in your own code or in, for example, on Stack Overflow. If you see if you remove the brackets and say no print statements, let's say, and same in IPython notebooks, there's just no need for it really. So it's not the problem per se. It's the kind of symptom of the problem. But I think it's actually really easy now to write Python 2.3 compatible code. So I'd encourage you to do that. And it's and there's a Python porting mailing list you can join for help. I'd like to thank Nathan Fadjian for his great help with the slides and discussions. And yeah, thank you very much. Thanks. No time for questions?